Alright, 8th grade. Today we're going to continue with kind of our equations theme that we've had through most of this year. But this time we're going to do a little bit differently. So what we have been doing is just solving an equation. The way we've been solving an equation is we're given something like x plus 2 equals 5. Our goal is to get x by itself, so we have x equals 3. And that's our answer, and that's really nice. But sometimes we've also seen these other kinds of equations that I'm going to call a linear equation. So we have linear equations that look something like y equals 3x plus 2. And this is a linear equation because if we graph it, it makes a line. So I could graph this and make a nice little line that looks something like that. And otherwise, that's pretty much it. It's a linear equation because when we graph it, it makes a line. That's why it's a line equation. And if we're trying to solve this, that I could pick any x I wanted to. So if I made x equal to 0, then y would be equal to 2 because y equals 3 times 0 plus 2, and y equals 2. Or I could say x equals 1, and then y would equal 5. And I could do this as long as I wanted and get as many different answers as I want. So there's an infinite number of ways to solve this linear equation, which is why we have systems of linear equations. So a system of equations, I'm going to write this is a very important definition. System of equations is going to be two or more linear equations. It can be two or more linear equations with two or more variables. Quick spoiler for a few lessons from now is we're going to end up finding that we need the same number of equations as we have number of variables to solve things well. So what that means is if we have two variables, like the y and x, what we're going to need is two different equations. And I want to give you guys a quick example of that. So if we have 3x plus 2y equals 7, and x equals 7 minus 3y, I want to see if 1, 2 works. So does 1, 2 work is my question. And looking at this, all you'd have to do is plug these numbers in and see if it works for both my equations. So x is 1, I would get 3 times 1 plus 2 times y is 2, equals 7. 3 times 1 is going to be 3 plus 4 equals 7, and that is true. On the other side I have x, which is 1, equals 7 minus 3 times y, which is 2. 1 equals 7 minus 6, also true. So that means that 1, 2 would be my answer here. But how do we find this? I can show you how to prove that something is right just by plugging it in and saying, yes, that works. But how do we find them? Today, what we're going to do is just by graphing it. So they are systems of linear equations, which means we can draw lines with them. And that's going to be our easiest way to solve this. So a quick example of a line we're going to do is going to be y equals x plus 3, and my other equation will be y equals 2x plus 1. And the way we've been graphing is just taking a couple numbers for x and y. Let's try negative 1, 0, and 1. So negative 1 plus 3 is going to be 2, 0 plus 3 is 3, and 1 plus 3 is going to be 4. And we can do that with the other equation just as well. Make a little t-chart for x's and y's on our graph. Negative 1, 0, and 1 for x, plug that in. 2 times negative 1 is negative 2, plus 1 is negative 1. 2 times 0 is 0, plus 1 is 1, and 2 times 1 is 2, plus 1 is going to be 3. So I got 3 points for each. That means I can try to make a graph, which I'll do right here. And looking at this graph, I'm going to plot my lines in the same colors I did above so we can tell them apart from each other still. So my red line, x of -1 has a y of 2, 0, 3, and 1, 4. So this line is going to be going 2, 3, 1, 2, 3, something like here. And that would be the line of y equals x plus 3. My second line is going to be y equals 2x plus 1. So I had -1 here, 0, 1 here, and 1, 3 right there. It's going to be going up and down this way. And I know this is a very ugly graph. That's all right. So what this is saying is that if I pick any point I want on this red line, any point I want at all, this equation here, my red equation, will be true. And if I pick any point I want on the blue line, then this equation here, my blue equation, will also be true. What I want to do is find a point where both the red equation and the blue equation are true. So where that is going to be is right here where they intersect. And where they intersect is actually going to be 2, 5. So I drew this a little nicer, it'd be easier to see. It's not too bad. Here's 1, so here's 2 and 5. And if I plug that back in, I can see that 5 equals 2 plus 3. That's good to go for my red equation. And for my blue equation, I can see that 5 equals 2 times 2 plus 1. It's also definitely true, so we're good to go. So all I did there was I took my two equations, I graphed them, I found where they intersected, and that was my solution. And because graphing's kind of messy sometimes, I also made sure to check at the end, plugging things back in and double checking my solution. And that's all we're going to be doing. We're going to be given two different equations, and we're going to be asked to graph them and find where they intersect, because that's where both equations are going to be true. So please make sure you do the lesson practice. We've got a few graphing problems. I do know one of the lesson practice problems involves using a calculator. If you would like to use the GeoGebra program we have, that would be awesome. If you can't quite figure it out, I know we haven't used it too much, you can just skip that. That's letter E. But other than that, you still need to do the lesson practice. And I will see you guys in class.